Hello and welcome to this video on tolerance. This video is intended for students in Essential Math 40S in the Precision Measurement Unit. Tolerance is a topic that deals with allowable values, and not uncommonly that deals with things like technical drawings like you see here. When you need things to fit together fairly precisely, there is usually a tolerance, and you can see that hiding in this picture here. We'll see what that means more in a second. But there's a tolerance for the size of things. If you need to put a bolt in a hole, the hole can't be too big or too small. It's got to be pretty much the right size. So what you've probably seen in your book, if you've gone through this lesson already in your class, is this diagram, which shows you some of the words that have to do with tolerance. Tolerance itself is the range of allowable values from a low end, and I'll put that up here, to a high end. Okay, a bolt could be, in a range of sizes, but it's got to be specific enough that it fits into the hole. It doesn't have to be perfectly measured down to the closest atom. It's impossible to do that. So as long as it's close enough, it will fit in the hole and snug in tight. So the tolerance is that range from low to high. It's usually expressed with one number, which is just how big this range is. And we'll see that with an example on the next slide in a minute. The nominal value is the target value. That means if everything was absolutely perfect, that's how big the thing you're talking about would be. Normally, the nominal value is halfway between the minimum value and the maximum value for the tolerance. It doesn't have to be, but for most of the examples you're going to see in this course, the nominal value is essentially the mean of the minimum and the maximum. The minimum value is the smallest the thing could be, and the maximum value is the biggest it could possibly be and still work. That's what gives you the tolerance range. And then it's important to note that to get from nominal to the minimum, or to get from nominal to the maximum, you have to go half the tolerance up or down, because you split this full tolerance into two halves, going from the middle to the top and the middle to the bottom. And that's where this plus 0.5 is a half, and minus 0.5 come from. You're just saying from your nominal value, add half of whatever the tolerance is to get to the maximum. Down here is an important little chart. You should definitely have this on a resource sheet for the exam. This tells you the 4 ways that you can write tolerance. I want to look at the second way just for a second here before we get to an example. The maximum value over minimum value. You can actually see that on this diagram. It's very small, but you can see tolerance written that way here. That whatever this hole is, or this piece is, and I don't know what this picture is, it has to be between 25.4 and 25.6 units big. That is the allowable tolerance for that piece. Okay, written in this form. There are 4 ways to write tolerance, and we'll look closer at those as we do an example. So, at a Pepsi bottling plant, each full 2-liter bottle of Pepsi should weigh 4.6 pounds with a tolerance of 0.2 pounds. That's how the machine would figure out if the bottle has not been overfilled or underfilled. It would weigh each bottle and just make sure it's the right weight. So it says write this measurement and tolerance in 4 different ways. So what I'm going to do before I get to the 4 different ways is I'm going to try to fill out this chart. And I would recommend that if you're struggling with this topic, that starting with this chart is a good way to go. The bottle should weigh 4.6 pounds. What that means is, and I'm going to make this chart over here again, the nominal value, what we want it to be, is 4.6. And the tolerance is 0.2 pounds. Now it's important to note that the tolerance is this full distance. So I don't go up 0.2 pounds. We'll get to that in a second. This whole distance is 0.2 of a pound. So in order to get the minimum and the maximum, if you look here, I have to add half the tolerance. Half of 0.2 is 0.1. If this is a weird number, you're having trouble with decimals, you can just do that on your calculator. Just go 0.2 divided by 2, because when you divide by 2, you get half. So 0.2 divided by 2 is 0.1. So to get from the nominal to the max, I want to add 0.1. And to get from the nominal to the minimum, I want to subtract 0.1. Notice I'm not adding 0.5, I'm adding half the tolerance. This is how you say half in math, right? So half of 0.2 is 0.1. So 4.6 plus 0.1 is 4.7. And 4.6 minus 0.1 is 4.5. What that means is the machine will accept any bottles that weigh between 4.5 pounds and 4.7 pounds. As long as it's in that range, it's considered good, and it'll be shipped out. Okay, so let's go through these and write out the 4 different ways that we can rewrite the tolerance statement here. The first way is the nominal value plus or minus half the tolerance. So the nominal value is 4.6, and then you put plus or minus, and then half the tolerance is 0.1, so plus or minus 0.1, and I'll put pounds at the end, LBS for pounds. Okay, that's the first way you could write that measurement. From 4.6 you go up 0.1 or down 0.1, and you're still okay. The next way to write it is maximum value over minimum value. So maximum's 4.7, so you write that on top, normally a little smaller, and then minimum value is 4.5. Notice you don't put a fraction line in here. This is not a fraction. It's just 2 numbers, one written over top of the other. And again, I'd like to point out, let me get my arrow out of the way there. Oh, I screwed that up. Apologies. Try that again. If you look in here, you can see that way of tolerance written with a number above another number. Okay, no fraction line. It is not a fraction. Okay, then the next 2 are a little goofy. Next one's minimum value. It says minus 0. Now the reason it says minus 0 is you can't go lower than the minimum. And then plus the full tolerance. So another way to write this is I could start at the minimum, which is 4.5. I write plus 0 down here because I can't go lower than, I write minus 0. Let's just fix that up. So 4.5 minus 0 because I can't go any lower than 4.5, but I can add on as much as 0.2, the full tolerance, right? I can go from 4.5 all the way up to 4.7. That's okay. That is a stretch of 0.2 pounds. So that's how you could write it the third way. And then the fourth way is similar, but just working at that backwards. You start at the maximum, which is 4.7. You'll notice this has a little plus 0 up here because you can't go any higher than 4.7. But I can minus a full 0.2 because from 4.7 I can go down all the way to 4.5, which is 0.2. So these 4 ways, and they would all have pounds after them. Please forgive my handwriting on this little computer tablet. These 4 ways are the 4 ways you have for rewriting a tolerance measurement. You should be able to take a measurement and rewrite it in all 4 of those ways, or be able to take these measurements and put them onto a chart like this to answer questions. I hope that helps a little bit with a tricky topic, and thanks for watching the video.